Today we'll be looking at 1.4, graphs of functions. And so we're not doing the warm-up today. I'm going to skip that. You guys can go ahead and try that out and see if you can come up with the different kinds of numbers. We're going to be talking about that today. First, how do you interpret a graph of a function on a coordinate plane? First, we're going to talk about the number system. Then we'll talk about thinking a little bit of a domain and range and how we use it on a coordinate plane. First, the real number system. So we're going to start at the very basic inside here. You see this is like kind of like rectangles within rectangles. So we're going to start at the very basic one down here, which is natural numbers. And we're going to build on these numbers as we go out across here. So the natural numbers, they're the numbers that you use to count. They also call them counting numbers. So let's give an example of that. Whenever you're really young, you start learning to count. You usually go 1, 2, 3, 4, so on. Those are called the natural numbers or the counting numbers. Then if we go to the next section here, it adds a little bit more. Actually, it adds very little more. Whole numbers are the same as counting numbers or the natural numbers. Same thing as the category below, but it also includes 0. So that's very simple. It's just 0, 1, 2, 3, 4, so on. And now we're going to actually go a little bit more broad, not just adding one extra number. Really, whole numbers and natural numbers have very little difference there. But now we're going to go to integers. An integer is the natural numbers and their opposites. And let's not forget, we also include 0. So this has positive and negative numbers. So just like the category below with the whole numbers, we have, let's put down here maybe. We have 0, 1, 2, 3, 4, so on. But we also have the negative counterparts. -1, -2, -3, and so on. So all the positive numbers, all the negatives, that makes up all the integers. Then we go to our biggest category here, so it engulfs all of these numbers. So this is literally any number that can be written as a fraction. Anything can be written as a fraction. Now, all the ones that we just talked about, they can all be written as fractions. All right, all the ones we just have down here, any number we pick down below here, and all the other categories can be written as fractions. I'll just pick one. -3. How's that written as a fraction? -3/1. Just like that. Any number, any whole number, any integer, any of these numbers down below can be written as a fraction just by putting it over 1. What else does this include? How about 0.3 repeating? Why does that work? Because it can be written as a fraction, can it? That's actually 1/3. So anything you could possibly think of that could be written as a fraction would work here. Any other good examples? I'm trying to think of what else. Like any decimal point you can, that ends here. So we have, right, 0.4. What would that be as a fraction? I don't know if you learned this before, but you can move the decimal over. And you would move the decimal over on the bottom too if you put it over 1. So this would be the same thing as, let's erase that actually. 0.4 is the same thing as 4/10. Or 2/5. So any decimal period can be written as a fraction, except if it falls under this category, irrational numbers. These numbers cannot be written as a fraction. So there are some, but most decimals can. This category is just kind of off on its own. It's not really involved in these ones as it grows. This is kind of a separate category. So what can you not have? In this particular case, to be irrational, you have to have non-terminating. That means it never ends and never repeats. There's not many of these, and it's hard to think of these examples. One example would be pi. Have you ever heard what pi was? That's the number 3.14159 goes on forever. Let's go ahead and write some of those out, which is 3.14159 dot, 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 dot. It goes on forever, and it never repeats in a pattern. There's some other ones out there, like some weird square root numbers that aren't nice square roots, like square root of 2. That's like 1.41 dot, dot, dot. So there's not many of these. It's just hard. I mean, there's a lot of them, but it's hard to think of them compared to all the other examples we just talked about. This is a category on its own. So these are irrational numbers. Rational numbers can be written as a fraction. Irrationals cannot. And as we do some of these problems later on, we're going to come back to this, and you're going to have to basically identify what kind of category these fall under. And some numbers can fall under more than one category. Domain. Try to memorize the domain as, if you can remember from last year, it's the set of all x values. The range. If you know that the domain is a set of all x values, the range has to be the set of all y values. Interval notation. This might be something new that you haven't seen before. A notation for representing an interval as a pair of numbers. So the numbers are endpoints of the interval. So you're either going to use parentheses for these endpoints, or you'll use brackets. They're going to show where the endpoints are excluded or included. I'm going to show you exactly what I mean with an example. Actually, we'll do quite a few examples with this. Okay, graph the following. -1 is a bracket of -1, comma 4 with a parenthesis. So let's talk about what the brackets mean. When we see brackets equals closed dots. When we see parentheses, I call them open circles. It's pretty good to know when you look at this. But in this particular case, with the set, one side of it will be closed, the other side of it will be open. And that's all we're going to do is we're going to look at the example here to graph it, go to -1, and look at what's beside it. It's a bracket, so that's got to be closed, right? -1's closed, so I'll put a closed dot. All the way at 4 is a parenthesis, so that's open circle, so put an open circle. And then we shade in between. Let's see if I can do a shade here. Shade in between. That would be from -1 included to 4 that's not included. So we're going to move away from using a number line and going to a coordinate plane. Use the graph below to answer the following questions. All blocks are 1 unit, so when we count these, they're only 1 unit. What is the domain? I usually choose just a capital D to show what the domain is going to be, and we'll put the notation. We're going to write something like this. From what to what? Domain is all the x values, so we're looking at the x-axis. And the way I do this, I usually just go the farthest left I can to the end point here. That's -2. Because only 2 blocks away. It's not very pretty, -2. It's a -2. So that's the first time, the farthest left that the graph goes. And in particular, this does not have a open circle. You'd be able to see if it was open, so it's closed. So we put a bracket, -2, comma. Then we're going to go towards the right and see where this ends. So as we go across the x-axis, the furthest we can go is what? 1, 2, 3, 4. Because if we go up, this is the end of the graph. And it is also closed. So we'll call that a 4 bracket. And that's it. Both ends are closed, and it says from -2 to 4, from left to right. Domain is usually left to right. Smallest number to the biggest number. What is the range? Same idea, but we're going to be going up and down. Let me change colors. We're going to be doing the y-axis. So let's talk about this. This is the lowest to the highest. So we're going lowest to the highest. So the lowest point that this ever goes down to is right here, and that would be the value of 1, right? Again, we don't have any open circles this time, so it's all brackets. So it's 1, 2, go as high as you can. 2, 3, 4. I have to stop at the very top because that's the part where it ends over here. 5, again, closed dot, bracket. That's the domain and the range of this graph. We're going to try another one. Again, all blocks are 1 unit. Use the graph below to answer the following questions. What is domain? Domain, x values. What is the furthest left you can go? 1, 2, 3, 4. -4. We're in the negative direction. And if we go up here, oh look, open circle. Although this may not be on your paper as an open circle. I think I added that. So open circle here. So it's going to be a parenthesis, -4. Because it's open, comma. Now we go to the right. This is 0. If we go over 1, 2, oh, we can't go 2. 1 is the first we can go over to the right. And we go straight down. That's a closed dot, no open circle there. So that's 1 bracket. Range. What is the range? The lowest you can go. Remember, it's lowest to highest. Change colors again. We'll go back to blue this time. The lowest we can go is -1, -2, -3 is the lowest. So we write -3. That's closed. Then we go up to the highest point we can go, going up the y-axis. 1, 2, 3, 4, 5. Go across, and you can see that's the highest you can go. So that would be 5 open circle or a parenthesis. And that one's done. Okay, for example 4, I would suggest maybe trying it yourself, maybe pausing the video and seeing if you can get it right, and then we'll go over it. So the domain is first, from left to right, the x values, that's 1, 2, 3. You can go all the way over to -3, which is right here. I know I wrote it off to the side here. But -3 is the first to the left. And that is open in this case, which again might be different on your paper, I'm not sure. That's a parenthesis. Comma, go all the way to the right. So 0, 1, 2. That's the first you can go to the right. And that would be closed because there's no open circles there. That's a bracket. Change colors, go to range. Again, that's lowest to highest. Look at the y-axis. So the lowest we can go is -1 with open or parenthesis. The highest we can go is 1, 2, 3. It's not even 3 because there's a peak up here. So we can actually go up to 4. And that would be, since there's no open circle, bracket. Hopefully you did pretty well with that one. But it was obviously the most difficult one we had because we had this kind of peaked and jagged edge here, whereas the other ones were just kind of straight, a little easier. All right, we have one more example, and then we're on the Team Huddle and Mastery, which I might do 1 or 2 of those with you as well. Okay, for the function below, we're going to find the following. The domain. It's really easy to do domain and range when you have a table because you don't have to do this set notation or the interval notation going from one number to the next, saying that everything's included. When you have a table, you just list out the values. Now, when we look at this, we got to figure out, well, what is x and what is y? And so maybe hopefully you can determine that, which one is x, which one's y, by looking at what we have here. Normally when we see this notation, right, we're usually used to seeing this as f of x, where the x would be inside. The same idea is happening here. It's g of j, where the j value is on the inside, just like it used to be x. It's the same thing happening here. So whatever's on the inside of the parentheses is your x value. So that means up here, the j by itself is x, and the bottom is y. Now you might have guessed that, but it's not always top x, bottom y. Sometimes it gets switched up. So the domain, once you figure out what the x values are, you just read them across. Usually, as we group them, we put them in the curly brackets. Just look like that. And we just write them out. A lot of times they say, like, write them least to greatest. It doesn't necessarily matter to me if you do that, but if you want to, you can. -7, 0, 6, 8, 12. So that would be the values from least to greatest. The range, same idea. As we figure out what y was, we put a bracket. And as you can see, there's two -5s. But we don't have to write that twice. So it's kind of useless to write it twice. So -5, 0, 3, and 22. So domain and range is pretty simple with just a table. A little harder with graphs. And the last question here, we've actually done this before, finding g of 0. We did this when we talked about, which one did we talk about? We talked about years. We were reading years. I think it was doing like gas prices in cents. We were going across and reading the year and then figuring out how much it costs. This is the same idea. Let's get rid of this. G of 0 means they want you to plug 0 in for j, because that's what's in the middle. So you're going to look at the j row, find 0, and go down and read it. Just like that. We've done this before with the tables, but maybe it looks a little different now. But g of 0 means they plugged in 0 for j. So you got to find j, go across, find 0, and then read down where it says g of that. So g of 0 is -5. So that's it for the lesson. Number 1, I put an open circle there so we can try that out for domain and range. I did want to go over like one of these ones, number 3. Probably number 3 and 4. Some other ones here. 3, identify each number as an integer, rational number, irrational, or real. So those are the options you have. And I'm not sure if I mentioned what real was. Let me go back here. Here. This is called the real number system. That means any of these categories would be considered real. So any number you can possibly think of is a real number, since all of these categories separately fall underneath the real number system. So we can say they're all real. So that's a weird thing to categorize them as. And it also says a number may belong to more than one set. So everything's real. So I'll just throw that in there. So these are all going to belong to more than one set. -97, what does that fall under? Is it an integer? It is. If you need to go back and look at your chart, you can see. Goodness gracious. Integer. Is it a rational number? Can be written as a fraction? Absolutely can be. So it's rational. Is it irrational? Well, no, that would mean it can't be written as a fraction. So that's it. B is real. Is it an integer? No, integers cannot be written like this if they can't be simplified. They can't. This would actually be decimal. So it's not going to work. So it's not an integer. Is it rational? Well, yeah, it's already written as a fraction. So it's definitely rational. And if it's written as a fraction, you can't be irrational. You can't be both. So that's all you can have there. And then this is real. And what else? Is it an integer? Square root of 18 is not a nice number. It's, what is it, like 4 point something? Maybe 4.45. Anyway, this one goes on for quite a while. And I don't think it repeats, and it looks like it goes on forever. It's one of those weird square root ones where you can't write it as a decimal, so it's not rational, so it happens to be irrational. A lot of the weird square root ones like this that don't come out to be nice numbers are usually like irrational. How about number 4? Give an example of a rational number that is not an integer. Well, we just actually talked about one like that. Rational that's not an integer, that's a fraction. So it's not like this. It'd be something like this. This is not an integer. So it'd be like 4/7. That's rational, not an integer. Give an example of a real number, so anything you can possibly think of, that is an integer, but it's not positive. So integers are the positive and the negative whole numbers. So it's real, that's easy to do. Integer, not positive. Negative, 5. That should work. I think I'm going to do... So number 3 should hopefully be easier for you to understand as far as being real and rational and whatnot. Same kind of question. One more I'm going to do is number 1 from the mastery. The graph at the right shows the relationship between the age of a grapefruit tree and the diameter of its trunk. Let A of D be the age of the grapefruit tree whose diameter is D inches. So the trunk diameter goes across the x-axis. We have the tree age across the y-axis. So we're going to use this graph here to answer the questions. Estimate the range of A. Range is the y values. So the y values start at, oh boy, we're going to have to guess. That's why it says estimate. The lowest number is probably like 1 or 2. I'll just say 1. And we don't have an open circle, so we're going to use brackets this time. This will be bracket, bracket. So it's 1, 2, and then go to the highest. 5, 10, 15, 20. Doesn't quite hit 25 either. That's right below there. So let's say 24. That would be the range. From lowest to highest. So it goes from about, we have data from 1 year old all the way to about 24 years old. Both closed dots, so brackets. Estimate A of 10. Well, if you look back up here, it says it's A of D, right? So A of D just means they're using 10 for the diameter. So if we go down here and look, where is the diameter 10? Right here. We have to go up and read the graph. And where does it hit? Maybe use a different color. It's right about here. So they want us to read, well, what is the age of that time? You know, A of D. It says A of D is the age of the grapefruit tree. So what's the age of the grapefruit tree? We have to estimate it probably, I'm not sure if it's exactly half. Maybe it is. That would probably be like, what, 17 years or 18 years or 17.5. So the way I would answer that would be A of 10 equals, if it's exactly half, maybe I'll estimate it and say 17.5 years old. That should be everything you need to know to do any of the homework, and you should be able to finish the mastery in the huddle, because I think I went over everything that could possibly come up in both cases. So that is it for 1-4.